All right, now we got some intense problems. Buckle up. Make sure your thinking caps are on because these are going to be intense. If triangle VSY is an isosceles triangle and its perimeter is less than 45 units, which side of VSY is the base? What is the perimeter of the triangle in this case? All right, there's three different cases, and we got to figure out which case is true. All right, are these two sides congruent in blue? What about these two sides congruent in red? Or what about these two sides congruent in purple? All right, so I'm on red, so let's just start with red. Case 1. All right, let's say, well, does 10 equal x plus 7? If that's the case, 3 is going to equal x. All right, and if that's the case, well, in case 1, do you notice how, well, VS is 10, YV is 10, but then SY, you get 2 times 3 minus 8, which is negative 2. A side length, a negative number. What planet are we on? Jupiter? That doesn't make sense here on planet Earth. Lengths can't be negative. All right, so that's out. Can't be that. So, let's do the blue case. All right, case 2. Case 1 didn't work. Well, let's say, well, is 10 and 2x minus 8 what we want? If that's the case, or if those two sides are congruent, we get 18 equals 2x, or 9 equals x. All right, if that's the case, well, obviously VS is 10, and then in this case, SY is 10, and then in this case, VY is 9 plus 7, which is 16. Now let's check the perimeter. The perimeter of the triangle would be 10 plus 16, 20 plus 16, 36. All right, we got 36 units. So it turns out case 2 is true. If we would have done the purple case, the other two sides, that would have been false as well. So we found it in our second try because we got a perimeter of 36 units. It's less than 45. So answering the question, the base would be VY. All right, and the perimeter equals 36 units. All right, so that one could have took a little bit longer. We were somewhat efficient, not the most efficient, but I like that problem because it's kind of a guess and check method. You kind of have to work and just finally figure it out. All right, number 5. If you know that triangle ABC, that AB is x plus 3, AC is 3x plus 2, and BC is 2x plus 3, and the perimeter of ABC is 20 units, show that ABC is scalene. All right, it says draw a picture. We really don't even have to draw a picture, but we will obey the problem. We will do what we're told. All right, here's some random triangle. We're going to show that it's scalene. So ABC, it says AC is 3x plus 2, AB is x plus 3, BC is 2x plus 3. So I drew a triangle. I labeled the sides. And we also know that the perimeter of this triangle is 20. So after I draw it, well, I don't know what x is. I don't know any particular side lengths, but I know that x plus 3 plus 2x plus 3 plus 3x plus 2 equals 20. All right, if you're wondering how I did that, I just added all the side lengths together like you do in a perimeter. All right, and then from here, just combining like terms. X, 2x, 3x gives me 6x. 3 plus 3 plus 2 gives me 8. That equals 20. Subtract 8 from both sides, you get 6x equals 12. Divide both sides by 6, and x equals 2. Okay, x equals 2. Nice. All right, now all I'm going to do is plug in 2 to each and every side and see what each side length is. It says that it's scalene, or we're going to show that it's scalene. So hopefully each time I plug in x, I get a different number. So one side's 8, one side's 5, one side is 7. So that's it. Draw a picture, add them all together, solve for x, plug it back in. All right, sweet. All right, now in this next one, triangle, so we're on number 6 now. Triangle ABC, AC and BC are perpendicular. It's the triangle ABC and isosceles triangle. Justify your answer. All right, so looking at this, all I know is that this AC and BC are perpendicular. So what does that mean? It means that this angle is going to be a right angle. So the 3x is the right angle. That equals 90. So x is going to equal 30. Now it's saying, is it an isosceles triangle? Well, I don't know. Let's go ahead and plug it in. I'm going to say, well, 30 plus 20 is 50. 2 times 30 minus 20. Oh, that only equals 40 degrees. All right. Not an isosceles triangle. All right. This looks like it will be a right scalene triangle. All right. Perpendicular, right angle, solved for x, plugged it back in. I don't know why I put degrees over here. That's kind of embarrassing. These aren't degrees. All right, side lengths aren't degrees. Fun fact, triangle angles. Let me write this out because I do see this as a common fact. Write this down. This is important. Angles of a triangle add to 180 degrees. Angles. Sides of triangles add to any number. All right, it could be anything. All right, so angles have to add to 180. Side lengths can add to any number. All right, which kind of leads us into this next one about perimeter. So looking at this one right here, what is the perimeter of the triangle below? Well, let's analyze. Well, equilateral, so all these sides are equal. But what does x equal? Well, I can pick any 2 sides. I'm just going to pick these 2. Why? Because I can. And set them equal to each other. If it's equilateral, they equal each other. So I can set this up and solve for x. All right, a bunch of math happens, and 4 equals x. All right. So technically, I only have to plug in x to one side, and all the sides should be the same. But this is going to be a fun way to check my work. If I plug in x there, I get 24. I get 3 times 4 plus 12. OMG, 24 again. 4 times 4 plus 8. I get 24. Sweet. So I successfully found x. I plugged it in every side and confirmed that x was correct because I got 24 for every side. So the perimeter, again, perimeters can add up to anything. In this case, we get 24 plus 24 plus 24 is a famous number known as 72. All right. So cool. Dense with the algebra. Hopefully you're having fun. Now we're going to do one proof. Now I said we're basically done with proofs, but they pop up here and there. All right, just for fun. So we're going to prove the base angle theorem to be true. How do we know this is true? This is exactly how. All right, so let's focus on this triangle right here. All right, this is the main thing. All right, but what we're going to say is AC and CB are congruent. So this red triangle is an isosceles triangle. So it's basically saying, given that it's an isosceles triangle, and we're giving you another piece of information, D is the midpoint of this right here. All right, so given. Then what do we know based on the definition of midpoint? Well, AD is congruent to BD, definition of midpoint. Next, well, look what we're doing right here. We put this thing in the middle, so we split these triangles up into two. We got this middle, the shared side, CD is congruent to CD by the reflexive property. Well, I got this triangle on the left. I got this triangle on the right. Turns out, OMG, those two triangles are congruent. All right? So triangle ADC is congruent to triangle BDC by side, side, side. So we take an isosceles triangle, kind of split it in half, and we can determine that the two halves of the isosceles triangles are congruent by side, side, side. Well, then, this is the good part. We know that their base angles, angle A and angle B, we know that these two angles are congruent because they're corresponding parts of a congruent triangle. All right, so remember that triangles are congruent. Everything in the triangles are congruent, so we know that the corresponding parts of the triangle are congruent themselves. Sweet. All right, that's it.